My name is Justine and welcome to today's quick lesson on calculus. We're going to be learning about limits using three types of algebraic expressions, namely polynomial, rational, and radical. By the end of this lesson, you're going to be learning how to solve limits like a pro. Let's jump in. First up are polynomials. Polynomials are algebraic expressions containing variables and coefficients using addition, subtraction, multiplication, and non-negative integer exponents. An example of this is 3x squared minus x plus 2. That's a polynomial. Polynomials are smooth and continuous. That's why in limits, you can just substitute the given where, for example, limit of 3x squared minus x plus 2, where x approaches to 2. You can just substitute it with the x. Now our first step is to substitute all of the x with 2. So we will just use 3 times 2 squared minus 2 plus 2. And we simplify this more and it will become 3 times 4 minus 2 plus 2. And 3 times 4 is 12 minus 2 plus 2. Now these two will just end up in 0, so our final answer will become 12. So the limit of 3x squared minus x plus 2 as x approaches to 2 is equals to 12. Next up are rational expressions. Rational expressions are fractions which both the numerator and the denominator are polynomials, and that the denominator cannot be equal to 0, otherwise it is undetermined or simply do not exist. This is an example of a rational expression. X squared plus 2x plus 3 all over x minus 1 squared. That's a rational expression. And now we'll turn this into a limit. So it will become limit of x squared plus 2x plus 3 all over x minus 1 squared as x approaches to 1. Since we cannot simply factor out the numerator, we will just substitute all the x's in this expression to 1. So it will become 1 squared plus 2 times 1 plus 3 all over 1 minus 1 squared. And to simplify this, it will become 1 plus 2 plus 3 all over 0 squared. And the answer here will become 6 over 0. Now, since the denominator is 0, this cannot simply exist, so the answer will be DNE, or do not exist. And finally, we have the radical expressions. These are expressions that contain a variable under a root or a radical. An example of this is square root of x plus 1. That's a radical expression. And sometimes when we substitute, we may get the answer 0 over 0, an indeterminate form of an answer. And that's where the trick called conjugate comes here. So now let's try a radical expression in limit form. Limit of square root of x minus 2 all over x minus 4, where x approaches to 4. Now we can't really just substitute all this 4 into all of our x's here, because when we do, we will get 4 square root of 4 minus 2 all over 4 minus 4. We simplify it, square root of 4 is 2, minus 2 over 0, 4 minus 4. And this is also just 0 over 0, which cannot be an answer. So, to not get this answer, we will use the trick called conjugate. Now back to our radical expression, where limit of square root of x minus 2 all over x minus 4, where x approaches to 4. Now instead of directly substituting all of the x with 4, we will use a trick called conjugate, where we get the numerator or the denominator with the radical sign and multiply it both with the numerator and the denominator here. But we just changed the sign. So in this case, square root of x minus 2 has the radical sign, which is the numerator. We will copy it, but just change the sign. So it will be square root of x plus 2, and then same with the denominator, square root of x plus 2. And now we multiply this, and we will get x minus 4 over x minus 4 multiplied by square root of x plus 2. Now since x times x is just x squared, we just remove the root sign, so we just get the x. And negative 2 multiplied by 2 is just negative 4, so we got the x minus 4. And since we can see here that they are the same, the numerator and the denominator, we will just cancel it out. And so what's left will be 1 over square root of x plus 2. Now, we can substitute it. So we will have 1 over square root of 4 plus 2. And the square root of 4 is 2, so it will be 1 over square root of 2 plus 2, which is 1 over 4. And that's how you use conjugate in radical expressions. And that's all for our quick guide on limits in calculus. If you like this video, like, comment, and subscribe, and hit the notification bells for more content like this. Thank you for watching. Bye!